Hi, we are commencing again with bioremediation. In our various classes, we have talked about bioremediation, which is a chapter and a component of environmental microbiology and public health, as well as it is a part of the environmental biotechnology. Bioremediation, as we considered, as we talked about it, it is a technique in which we are using, our human are using microorganisms to clean the pollution from the environment because microorganisms have potential to produce various type of pollutant, various type of enzymes to break down the various type of pollutants from this globe. And in we talked in this talk we have argumented and we established the fact that bioremediation is a cheap technology because this bioremediation process is going naturally on growth. And microorganisms are adopted to manage, to function, to remove pollutants from this environment because they have metabolic diversity. So we have to talk again with this bioremediation. And we also talked the mechanism of the bioremediation in which microorganisms are producing certain enzymes which are breaking down the complex structure of pollutant and converting them into simplest form or less toxic form. So by it is going again bioremediation. What type of treatment technologies are in use to remove contaminants from the environment? If we are talking about environmental microbiology, we must be ensured that another which type of activities and techniques are applicable are used throughout globe to remove the pollutants from this planet, from the earth, from the environment. Because environmental health is most important for the living organism, especially for the human being. If environmental health is not good, and we never can expect the people and the living organisms who are living in that environment, their health will be good. If there are pollutants in an environment, directly or indirectly, but by various means, they are affecting the life on this globe. So in this regard, we have many techniques. Over here you can see soil vapor extraction, the pollutant where pollution has occurred, we are trying to convert it into vapor and to transfer it from that surface to air. We are using air sparging. We are introducing air for oxidation as well as to increase microbial population. Bioremediation process in which we discussed in detail thermal absorption, soil washing, chemical dehalogenation, soil extraction, in situ soil flushing. If you will see over here in this slide, most of the techniques except the bioremediation all are have more limitations as well as these are much expensive. Soil vapor extraction, we need special technology. Air sparging, we need mechanical support. Thermal desorption, we need uh, much energy. Soil washing also cost, having high cost. Chemical dehalogenation also need cost and other secondary consequences, chemical consequences. Soil extraction, others are most expensive except bioremediation because bioremediation is naturally ongoing process on this globe to clean the environment. So other techniques are not suitable, other techniques are costly, other techniques have limitations. What makes bioremediation is promising approach? This is the main content. This is the main thing. why we are using bioremediation, why we are preferring bioremediation compared to another technologies. As a student of microbiology and a student of the environmental microbiology, this is very important. We should keep our mind clear that why we are going for the bioremediation compared to other techniques. Number one, permanence. Contaminant is degraded. Therefore, we are preferring bioremediation in which, with a cascade of biological and microbiological reactions, the contaminant is going to completely degrade from this environment. Therefore, this is considered the most suitable and most acceptable approach because it finishes pollutant from the surface and converts it into its elemental form. Therefore, we are preferring contaminant must be degraded, contaminant must be finished, contaminant must be converted into its elemental form. Therefore, we are preferring the bioremediation process because at first step, one type of microbial population will convert into second form. There another microbial enzymes will react and will convert into another form, and gradually at last it will be converted into elemental form as we discussed in types of pollutants, where we have discussed about the example of the benzene, example of the toluene, and some another compounds, where initial form was converted into middle form was converted into tertiary form was converted into last linear form, and last in elemental form. Therefore, we are uh, preferring the bioremediation. It have permanent solution. Number two, potentially low cost, 60 to 90% less than other technologies. It is very cheap. Nothing is required except the microbial population which is growing our on that site. Just we have to enhance the growth of those microbial populations who are growing over there by adding some air, by adding some fertilizer, by adding some nutrients. We have to increase, we have to enhance the microbial population over there. And it have less cost, 60 to 90% less cost. Therefore, it is preferred compared to other bioremediation technologies. Economics of in situ versus ex situ bioremediation of contaminated soil. So here we have to understand two things. We have discussed in another slide, in another lecture, in situ and what is our ex situ. In situ means, please be clear, in situ means treatment of pollutant at the place where accident happened, where pollution is present on environment, that is called in situ bioremediation. In situ bioremediation is treatment of pollutant at the site of the environment where pollution is present, is called in situ bioremediation. And ex situ bioremediation means transfer that soil, that environmental uh, sector to the treatment site, to other place, that is called ex situ. Suppose there is a field where pollution happened, where accident or oil spill happened, we must have to load that soil in trucks and another vehicles to transport to the site where we want to treat that contamination. So that is called ex situ bioremediation. So these two are same same activity, all are bioremediation, but in situ is treatment of pollutant at the site where pollution happens, and ex situ transfer of the polluted material towards the site of the treatment means to another place. Cost of treating contaminated soil in place means in situ bioremediation is $80 to $100 per ton in situ. If you want to treat pollution at that site where pollution happened, so that is having cost $80 to $100 per ton, and the cost of excavating and trucking contaminated soil off for incineration is $400 per ton. So ex situ bioremediation is have high cost. Therefore, people are not preferring ex situ bioremediation because we have to excavate that soil, we have to dig that soil, we have to load that soil on trucks, we have to transport that soil to the treatment site, we have to offload that soil, and we have to treat that soil. That can increase more than $400 per ton. So people are not preferring ex situ bioremediation. Our 90% of the chemical substances classified as hazardous today can be biodegraded. So bioremediation is most acceptable, suitable technique because it can degrade almost 90% of the chemical pollutants can degrade easily. So most of the elements are coming, most of the pollutants are coming in 90%. Only 10% which are xenobiotic and some elements. For that we can use the phytoremediation process. Our xenobiotics are some elements which are easily not degradable, are some recalcitrant pollutants for which we can use another strategies. But for more than 90% pollutants, we can use bioremediation. So bioremediation is most acceptable and most suitable and affordable technique to treat the pollutants on globe Earth. Okay, bioremediation techniques. There are four types of bioremediation techniques. Number one, natural attenuation. We will talk on it in detail. In situ bioremediation, ex situ bioremediation, and phytoremediation. These are four techniques uh, used in bioremediation to treat any pollutant by means of biological cells, bacterial cells, plant cells, eukaryotic cells, or fungal cells. Okay, natural attenuation we can see over here. Natural attenuation means the process. So we are talking about the natural attenuation, monitored natural attenuation, and enhanced natural attenuation. So natural attenuation is the process where pollution happens, okay, where pollutant is spilled. We have to give time, just we have to circle that place that no one will go to that site, and gradually naturally living microorganisms, they will decompose, they will degrade this pollutant. And the time to time just we have to check the quantity of the pollutant over there, how much has been degraded with passage of time and how much is remaining. And the another process is monitor the natural attenuation, where you have to uh, check control, where you have to check, monitor. Okay, you are putting microorganisms. If there is a place where pollution is present, we have to put some microorganisms over here, and we have to monitor this site that daily, per time, per day, how much concentration of pollutant is going to reduce. And enhanced natural attenuation if we are boosting and exciting the microorganism to decompose that pollutant is called enhanced natural attenuation. So this type of natural attenuation is going common in forest, in every ecological need, in trenches, in oceans, in bottoms of the lakes, ponds, and rivers, in sediments, and monitored natural attenuation is going in sites where less population is present and there is no chance of the damaging of life and no entrance of pollutant in food chain is possible. But enhanced natural attenuation is where it's very toxic and natural, and we are very afraid that this pollutant will go in food chain and will cause secondary consequences of the health and environment, where we are trying to degrade pollutant rapidly. Therefore, we are enhancing, we are exciting, we are increasing the microbial load to decompose that pollutant that is called enhanced natural attenuation. If you will see over here, this is an example of the natural attenuation. If you will see typical hydrocarbon plum undergoing natural bioremediation, cross section, and plan view. In A, we will discuss uh, this section, cross section, and this we will see a plan section. Okay, what happens? Suppose this is pollutant, it went over here due to a spill of this thing in this soil. See carefully over here, please. This is the pollutant which came from this to underground tank. Underground storage tank is leaked, and petroleum, gas, or whatsoever thing was there, chemical was there, it went into the soil. What will be? Some component, volatile component is with passage of time will go into the environment. Okay. Some will go into the soil and will spread in a particular layer. Okay. Some will go over here. What will be? When pollutant is going over there, from its surrounding, it is buffering and it is neutralization will start. Microbial populations which are present over here, they will interact. Dilution will take place due to components which are present in surrounding soil. Uncontaminated groundwater also will dilute it. Groundwater will also will dilute it. And from upper side, clean groundwater also will dilute it. Oxygen also will oxidize it. And aerobic unsaturated zone also will try to decompose it because it is a foreign particle, foreign substance for this soil. And existing microbial populations will also start to decompose it. So gradually what will be? This zone, this small shadow zone will increase, this small shadow zone will increase, and gradually this will be reduced. So this is called natural attenuation. There will be a time the concentration of this pollutant which was spilled over here will be finished, but it will take more time, and we cannot say about any chemical how much time it will take. And here if you will see, this is the pollutant, this is spilled, and aerobic microorganism will react from its border sides and will try to decompose it, and from inner side oxygenated and uncontaminated groundwater also will react, and gradually this will be reduced. Similarly, here we can see oil spill if is there. First of all, methanogenetic bacteria will react gradually, sulfates will react, iron will react with it, nitrate and manganese will react it, and oxygen and aerobic environment will react it. So gradually this will be reduced, and pollutant will be, there will be a time the pollutant concentration will be minimized and minimized. So Another technique we can use the bioventing. This is typical bioventing system in which what we are doing. Suppose there is a pollutant inside of the soil. Okay. Due to leakage of any underground tank, this chemical went into the soil. We want to remediate it. We want to clean it because if we will not clean it, what will be? This will go into the water and will cause secondary uh, consequences, contaminated soil. Okay, here we are digging monitoring points, monitoring two wells. One well near to the contaminated site, and another well after some specific distance. We will measure the concentration of pollutant over here, and we also will measure the concentration of pollutant over here. Okay, and we also will check the concentration of pollutant over here. So what we will do? With a mechanical source, we will inject with blower, we will inject air through this line. So what will be? Air will enter into the contaminant. If microbes are there, this will activate aerobic environment over there, and aerobic microbial population will start to decompose this pollutant. And in another way, oxygen will oxidize the pollutant and convert it into binary compound. And the third, it will spread it at its surrounding, and its concentration and magnitude will be reduced. So up to this, we want to stop it, and in next class, we will start from here. So here we talked about the types of the bioremediation. Why we are using bioremediation? This was the main thing. We are using micro bioremediation because it is cheap. It have no secondary consequences, and it is easy. And more than 90% pollutants can be degraded through this bioremediation technique. And we are going to study more bioremediation techniques in which we discussed bioventing to clean the pollutant inside of the soil. How we can do? We talked about it. You have to go through Prescott and environmental microbiology to read it in detail. I hope you will try to understand. You will read. You will discuss with book. You will discuss with your friends. You can discuss with your instructor, and you can find a good solution. If you will not read, you should promise and you should live on it that you never can learn anything good. Thank you. Have a nice time.